Okay, so here's the stuff from C 8.8. We looked at this idea of equilibrium and the fact that it occurred in what's called a closed system when you've got the forward and reverse reactions occurring at the same rate. Then we had a look at this relatively confusing higher tier stuff about changing conditions and the effect that's going to have on the yield of our product. Now, this lesson is basically going into this stuff in a lot more detail. All right, so if you were not too happy about this, have a little look at this one and hopefully we might make it a bit clearer. Okay, so the knowledge and skills from this lesson look relatively horrendous. Essentially, the reason they look so bad, I'm just going to click through it actually just to get them all up there. Right, the reason they look so bad is because essentially what they've done is they've talked about the way you can change conditions, right, so changing the concentration, and then given an in-depth description of what happens in each case. So this first block is all about changing concentration, this second block is all about changing temperature, and this third block is all about changing pressure. So obviously I'm going to go through all of these things. If you want to have a bit of a read of that, feel free to pause it, but I'm going to just carry on at this point. Right, quick reminder about what this is all about. So this guy, Le Chatelier, there was his principle. I'm not going to read that to you again. We did this in the last lesson. But essentially what this means, remember, is that if we do something to a reaction at equilibrium, it will try to do the opposite. So today's lesson, we're going to try and look at some detail at what happens when we change these conditions, and also what sort of things you might need to actually write in an exam question to get some marks. Okay, so the first thing we're going to look at is concentration. Now, concentration really only applies to solutions, all right? So therefore, you're going to have your reactants, which are going to be a solution, and products, which will be a solution. So if you increase the concentration of a reactant, the equilibrium will move to the right to oppose the change. This will increase the yield of the product. So if you add more of your reactant, the equilibrium will move to the right-hand side. Okay, why? Well, because it tries to oppose the change, so it tries to remove that reactant by shifting the equilibrium to the right, and therefore you will get more products. Okay. Right, if you decrease the concentration of reactant, the equilibrium will move to the left-hand side. Right, what's that all about then? Well, if you basically remove this stuff, so you decrease the concentration, right, the equilibrium, remember, tries to oppose the change. So therefore, the products will then reform the reactant, so the equilibrium moves to the left. This will decrease the yield of product. Okay, so that's your possibility in terms of concentration. Right, next slide. Okay, so next up, let's look at temperature and how that affects the equilibrium. Okay, so they will have to tell you whether it is exothermic or endothermic in the forward direction. Most reactions are exothermic in the forward direction, but not all. But this will either be written on the arrow or written somewhere in the exam question. So if you decrease the temperature, so if you make it colder, the equilibrium will move to the right to oppose the change, right? Basically, remember, if you do something to it, if you make it colder, it doesn't like that. It will try and do the opposite. It will try and heat itself up. So it will move in the exothermic direction. So that is to the right. Why? Because the forward reaction is exothermic. And what will that do? Well, it will increase the yield, increase the amount of your product. Okay, so if we increase the temperature, so we make it hotter, doesn't like that either. All right, it tries to cool itself back down again, so it will then go in the endothermic direction, so it will move to the left and make more reactant. Right, why does it do that? Well, again, because the forward reaction is exothermic. And what will that do to the products? Well, if it's moving to the left, it will decrease the yield of product. Right, now, you will notice that I wrote that the forward reaction is exothermic in the first one, but then I wrote it again here, and you might wonder if that was a typo. Well, it's not, because you don't just literally have to write the opposite, okay? So the forward reaction being exothermic just means that when you cool it down, it will go in the forward direction, but when you heat it up, it will go in the reverse direction. I could have written here, because the reverse reaction is endothermic. That would also have been absolutely true. Basically, the exam board assumes that if you've written the forward reaction is exothermic, then the assumption is the reverse reaction is endothermic. Okay, so in conditions, last one we're going to look at is pressure. So if we have reactants, R for reactants, and P for products, you will notice we have two reactant particles on the left-hand side. So this is two separate R's. So there are two particles on the left and a molecule of P2, our product, on the right. So one particle on the right. That's going to be important when we look at how this works. So if you increase the pressure, the equilibrium will move to the right. Why is that? Well, obviously it's to oppose the change. If you do something to the system, it tries to do the opposite. But why does it do that? Well, because there are fewer molecules on the right-hand side. Okay, so pressure is all about things bouncing around. So there are two particles of R on the left, right, and there's one particle of P on the right. So therefore, this side, the left side, would exert a greater pressure. So if you increase the pressure, it tries to reduce it. So it goes to the right-hand side, therefore increasing the yield of P2. If you decrease the pressure on the system, the equilibrium will move to the left-hand side. Why will it move to the left-hand side? Well, same kind of reason, because there are fewer particles on the right. Therefore, if you decrease the pressure, it will try and increase the pressure, therefore moving the equilibrium to the left. Therefore, the yield of P will go down. Okay, so this is a classic example of a reversible reaction. In this particular reaction, we have something called nitrogen dioxide, NO2, which is gaseous, and it exists in an equilibrium with something called dinitrogen tetroxide, which is also gaseous. The visual difference is this one is brown, the nitrogen dioxide is brown, and the nitrogen tetraoxide is colourless. Now this is one that I would be showing you in the lab if we were in school, but you can have a little look at the version on YouTube below. I believe in that particular one they're looking at how you change the temperature and how that affects the position of equilibrium. So let's just have a quick chat about how changing conditions of this would affect the equilibrium and hence the colour. So first up then, let's talk about temperature. So if this was obviously in a closed system, you would have a mixture of brown and colourless gases, and so it would obviously look sort of light brownish, I guess. If you were to then cool this down, so make it colder, of course what Le Chatelier's principle tells us is that the system will then try and oppose the change. So if you like, if you do something to it, it tries to do the opposite. So if you try and cool it down, it will try and heat itself up, which means it will go in the exothermic direction. So it will move to the right. So the equilibrium will move to the right, and therefore you will make more of the N2O4, and therefore the brown colour will begin to fade because obviously it will become more colourless. The opposite is true. So if you were to heat it up, then it would try and oppose a change. So it would move in the endothermic direction. It would try and make itself colder, right? Therefore, the mixture would appear to become darker brown as the equilibrium moves to the left. Okay, so that's temperature. This one you can also look at pressure because you've got gases here. So whenever you're looking at pressure, it's all about looking at the number of molecules on each side. So on the left side, we have two molecules of NO2. So there are two molecules on the left side. On the right side, we just have one molecule of N2O4. So when you're looking at pressure, it's all about looking at the numbers in front of those molecules when you're counting them up. So two on the left, one on the right. So if you were to increase the pressure on this system, it would try to oppose that change. So it would try to decrease the pressure. So one molecule is going to exert a lower pressure than two. So if it was trying to oppose that change, it would move to the right. So if you increase the pressure, it always moves to the side with the smallest number of molecules. So it would move to the right and become less brown, more colourless. And if you were to decrease the pressure, it would try to increase it. So it would move to the left, and therefore the thing would appear darker brown. Okay, so what we're going to look at now is a typical exam question. Like I said, this stuff is one of a very small number of things that are higher tier only on paper 2. There's much more higher tier stuff on paper 1, but because there's only a small number of things that are higher tier only on paper 2, you can pretty much guarantee they're going to come up. Right, so there we go. In industry, methanol, if you don't know what that is, that's this stuff here, right, it's produced by reacting carbon monoxide, there it is, with hydrogen. And they've given you the equation. That's nice. The reaction is carried out at a temperature of 250 degrees C and a pressure of 100 atmospheres. Interesting. The forward reaction is exothermic. There you go. I told you at some point they'd have to tell you this. It's not written on the arrow this time. It's just stated. So explain what happens to the yield of methanol. That's this stuff. So the amount of that if a temperature higher than 250 is used. Right. So what they're asking here is what happens to the yield of methanol when you increase the temperature. Okay, so if you think about this whole system, if you heat it up, so you increase the temperature, it will try and cool itself down. So it will go in the endothermic direction. So which way is that? Well, they've told us the forward reaction is exo, so the reverse reaction must be endo. So if you heat this up, the equilibrium will move to the left and reduce the yield of methanol, right? Because the reverse reaction is endothermic, or if you like, because the forward reaction is exothermic. Right, fine. Part B, it says a pressure of 100 atmospheres is used instead of atmospheric pressure. Okay, so they're hoping you're going to realise that atmospheric pressure is significantly less than 100 atmospheres, i.e. about 1 atmosphere, hence atmospheric pressure. Right, the higher pressure gives a greater yield of methanol and an increased rate of reaction. Explain why. Right. This here, the rate of reaction, this is something people commonly get confused with because you have to be clear that the rate and the yield are two separate things. And the final part of this lesson is going to be looking at those two things combined. So a high pressure gives a greater yield of methanol apparently, and we've got to explain why. So let's have a little look. So pressure is all about number of particles. And remember, you're looking at the numbers in front. So we have 2 hydrogen particles, 1 carbon monoxide particle on the left, so a total of 3 particles on the left-hand side. The right-hand side, we literally just have one methanol particle. So if you increase the pressure, the equilibrium will move to the right-hand side because there are fewer particles on the right-hand side, all right, and therefore that will oppose the change. Okay, it also wants to know why it increases the rate. Well, if you go all the way back to C8 point whatever it was when we talked about pressure, remember if the pressure, it's all about collisions. So if you increase the pressure, there will be more particles in a given volume and therefore there will be more successful collisions. So that is why the rate increases. But these two things, rate and yield, right, you've got to be careful because yield will change depending on whether the reaction is exo or endo. Rate will always be increased at higher pressure and always increased at higher temperature. Whereas, like I say, yield can change whether it's exo or endo, or also look at the number of particles. Right, let's have a look at the official mark scheme and see how we did. Okay, so here's the same question. I've chopped a little bit out, but the actual mark scheme says this. Right, okay, so explain what happens to the yield of methanol. If it's a smaller yield, well, there is, yes. So the yield will go down. Allow less methanol produced. Yeah, fair enough. 2 marks. What was the second one? Because it goes in the endothermic direction or favours the endothermic reaction, that's fine. Or if you just said the equilibrium shifts to the left. I've been stating both these things. Notice in this case, I only need one of them. I would put them both, to be honest. Then we had this business about pressure and explaining that, explain why 3 marks. Okay, so what do they want? Okay, so they wanted a statement about the yield. The equilibrium position moves to the product side. Yes, so that allow equilibrium moves to the right. So the equilibrium moves to the right because there are fewer molecules or moles or particles on the product side or the right-hand side. That's fine. So fewer particles on the right-hand side. That is true. And the final mark is about the rate. And there are more collisions per unit time. Right, this is interesting. So I did chop off here. It said ignore just more collisions. So they want you to be specific. There are more collisions in a specific time. That, of course, is what this means, isn't it? Increases collision frequency. If you say that, then, of course, that is the same as saying per unit time. Okay, so for these next 3 slides, I would like you to have a go at filling in the tables, and then the 3 slides after that are going to have the answers in. So this is trying to make sure that you get your head around the difference between rate, and yield. Right, to be clear, we should be in a situation where this row and these two boxes and these two boxes will be exactly the same every time. If you increase the temperature, the effect on the rate will always be the same. If you increase the temperature, the effect on the rate will always be the same, etc., etc. Right, so that's the point here. So feel free to copy and paste once you've got it sorted. However, the yield will not always be the same. You have to look and see if it's exo or endothermic. The other tables are obviously looking at concentration. So again, with concentration, if you increase it, the rate change will always be the same. So you should be okay, but the yield will obviously change slightly. And the other one is pressure. Again, if you increase the pressure of something, then of course it will always increase the rate. But if you're looking at yield, you have to look at the number of particles of products and reactants. So next 3 slides, I'm not going to chat over, see if you can have a go at them, and then the following 3 will have the answers. Okay, so here's the answers to the first of those 3 slides. This is the temperature one. So if you increase the temperature, the rate will always increase. So notice exactly the same here. Why? Because there are more successful collisions in a given time. Of course there are. All right. Same down here as well. Decreasing the temperature obviously has the opposite effect. All right. Doesn't matter what the reaction is. Doesn't matter if it's exo or endo. That will always be the case. However, notice the yield. It does matter whether it's exo or endo. So if you increase the temperature, right, the yield will decrease. Why? Because the equilibrium moves to the left, favors the endothermic direction, right, and therefore you will get less product. Right, I'm not particularly going to chat about all the rest of these because you can have a little look at those. It's very common that they put rate and yield questions in the same exam question because people get so messed up and confused about these. So it's very important that you get your head around this stuff. Right, so this is the final slide with the knowledge and skills. I'm going to press the magic button many times. There it is. All right, and there's all that horrible stuff that we've been doing. Feel free to have a bit of a read of it. As I said, essentially, it's looking at those 3 things: concentration, temperature, and pressure, and how they affect the position of equilibrium. The reason I put all this horrendously text-dense stuff on here is because I hope you realise that all these knowledge and skills are literally directly from the specification. So this is exactly what it says you're supposed to be able to do. All right, so that is why it's there.